Hey guys, Andy here. Alright, so if you haven't seen my previous video on these light bulbs, please watch it first. It quickly, I don't know how long the video is, but I try to quickly go over the most important information on these 12 to 24 volt LED light bulbs. So please watch it first to understand the most important things of this light. Now, in this video, we're going to be going over how to dim them. What is the most efficient way of dimming them? And I do it three different ways. First things first, we are using a lux meter to determine dimming. You absolutely need one of these when you're researching light bulbs at any stage. You need a lux meter. I will fight you if you don't agree with me. Alright, so I would say that these bulbs put out just as much light as these ones. These are pretty nice. They have a flicker problem. These are normal 110 LED light bulbs. I paid like $3 for them. These are like $6.50 Canadian, note you. So Americans get a 27% discount. So just keep that in mind. You times the number by 0.73, I think, right now to get American numbers. So yeah, it's pretty sweet for you guys. Alright, so this light bulb has a 15.5 watts and 1600 lumens, 2700K light output. So I'd say this is claimed to be a 900 lux, warm, so it brings out a yellow color. Yellow is good for living spaces. A white light bulb color is good for workspaces because a white light will bring out the true color of objects that you're working on. So it's just a good rule of thumb. If you want to be in the living room, relaxing, calm, chill, you do a yellow, what's called a warm white. If you're at a desk or doing any kind of artwork or something that requires you to see the true color of an object, the proper color, you want a white, like a cool white or a white, like, yeah. So anyways, the reason why is like this is more like simulating the sun is more yellow. That's a very dumbed down version. You can obviously correct me on this, but this is just dumbing it down to a simple, quick go. So anyways, I'd compare the two. So I did a very simple test. I took my lux meter and I shoved it right up against it, because the other option was I'd take this whole unit, I'd put it up on the ceiling, and then I'd put this down on the ground and have about a 5 foot distance from this sensor to this light, and I would measure that. And I don't feel like there's any point to that, because we're working on dimming, and dimming is based off of your personal preference, not off of how many lux there is. So I felt like the lux should just be a reference to keep them all on the same page. So every single time it's always the same distance. That just tells us that they're all at the same percentage of brightness based off lux. So hopefully you're still following me. I know it's anyways. So let's move on. We did 3 different methods. This $7 buck converter, this $20 buck boost converter with a digital display. It's a little finicky, but you can control it very easily. It gives you a readout, which is nice. I liked that. And this really big potentiometer, this big fat potentiometer. So 3 different methods of dimming your lights. Can you guess which one was a fire hazard? It's a trick question because they're all fucking fire hazards. Alright, so I did a lot of paperwork, guys. Alright, what I'm gonna do for you guys is I'm gonna set this up. Alright. So you can pause it and look through these numbers. They're a little confusing because things really fell apart near the end. This is the potentiometer. So these numbers here are the potentiometer. These are my giant buck converter. It was super inefficient. I just had to stop testing altogether. The 1440 watt buck converter. Holy crap, is that thing inefficient, which is really bad news for me, but sometimes you need that. Okay, and then this is the buck boost converter. This $20 unit here is these numbers, and I messed them up because I was still learning how to set up my graph. So these are input values, these are output values. I did that so backwards. I should have only focused on input values, but because you only care about how much power is being consumed by the batteries, you don't care what the light bulb's doing as long as it's putting out light. This is the buck converter. Okay, let's see. Alright, the $7 buck converter. Yeah, so I did two different ways as well, because there was an issue. It wasn't just simply dimming, because there's also adjusting only voltage or only amperage, and you get different results. And yeah, so you can look at these numbers. So this is when I'm dropping the voltage only setting. This is when I'm only dropping the amperage. This column here is the only column that matters, and how many lux are being output. So you can look that over, but it's TLDR, guys. TLDR. So I simplified it. Alright, it's a little difficult to see. Alright, this is the buck boost converter. This is the buck converter doing voltage or amperage. And this is using that potentiometer, a really big one. Okay, so the potentiometer literally caught fire. Would you like to see it? I bet you do. I bet you don't believe me that it catches fire. Well, it sure as fuck does. Alright, how do we hook this up now? Trying to find the right cable. Okay, there we go. It's a rat's nest, guys. It's a rat's nest. Alright, you ready for this shit? You ready for this? Watch. This thing is literally a goddamn fire hazard. Is it gonna do it? Oh yeah, it is. Oh yeah. Do you see that? Oh, we got a secondary light bulb going on here, guys. Look at that. Holy shit, I better unplug it. This thing starts pouring smoke. I'm not even joking. Like right here, this hole, like dark gray smoke starts pouring out of it if you leave it long enough. And I need this thing for other research, so I'm not gonna do any more damage to it, but it like straight up turns into a cook stove. It's dangerous, man. It's so dangerous. But anyways, I wanted to prove a point, so that's fine, right? So the potentiometer at full power, full brightness, 675 lux, hurts the eyes to look at. 37 watts. I couldn't do at 500 lux. We're burning down the house, so I couldn't even do the measurements. I couldn't even leave it for a few minutes. I couldn't leave it for 30 seconds or 20 seconds. All right, so 250. We're doing 30 watts compared to 10 watts, 12 watts. So kind of yikes. And then at 50, we're doing 54 watts compared to 2 watts. All right, the batteries are consuming 2 watts versus 54 watts. So I hope that explains enough of it for you, right? So, all right, so what was the best? Well, surprisingly, the $7 buck converter was the best option, as we can see with these numbers. So at 500 lux, we're 33 versus, actually this is the odd part, 33 versus 28 or 37. So if you drop the amperage only, it's inefficient. But at 250, it's actually more efficient. But I think that's it's a 0.1 watt difference. So I think that could be an error, because I was having trouble with the lux meter getting it to 50. Actually, no, it was only 50 that I was having an issue at. So when you're dropping amperage, this here could just be an issue, like 0.5 watts. It could be an issue. I know that at one point I was accidentally at 60 lux instead of 50 lux. So based off this number right here, 37 versus 28, it's obviously better to drop the voltage, not the amperage, because on these things, there's two different potentiometers, one for voltage, one for amperage. So based off those numbers, because the other ones are so close, this is a margin of error, so it can be thrown out the window. You say these are equal. This is a difference of like half a watt, which is most likely the difference of 60 lux to 50 lux, because I had that issue. But it's not a big deal. This number is the only one that seems to matter, because it's such a massive difference between the two. So we're going to say that the most efficient way is also technically the cheapest way, because this potentiometer is not cheap, and it gets so hot. Holy crap. So a $7 Canadian times by 0.73 to get US dollars, right? So $5 American, probably. All right, $7 will dim the lights, and the batteries will only at like very dim lights. So at nighttime, my living room or my kitchen, I like to keep that light on, but very dim, just enough to give like moonlight type. It would only consume 2.5 watts instead of 37 watts. Now the buck boost converter, I'm glad this thing was more energy hungry, because I didn't feel like spending $20 versus $7. And it's more difficult to change the voltage, even though you have more information and all that. Like, this is just a dial. It'll, like, basically you'd solder off this potentiometer and then put on a bigger one, like this one here. You'd get one of these soldered on. That is what I'm gonna do. I'm gonna do this for this place. For my garage, I'm gonna be running. I bought more of these. I bought some cool. So I have warm here. I ordered some cool one. I'm gonna test out the cool ones when they come in. It's probably gonna take a month. So that'll be a January video, January 2019. I'll do a video on the white, the whites. These are the yellow ones. That's stupid. Anyways, so that's what I'm gonna do. All right. So you'd have your batteries, and then you directly connect it to this guy, and you'd unsolder this guy, and you'd solder on one of these. They're cheap. You can buy lots of them for very cheap. You'd solder on this, and then you'd have a dial, and really simple to, and then, well, it'd be nice. The most important thing, though, where is it? You're better off with one that does a click. It has a light switch, like an on-off switch. If you can see it, when you bring the dial all the way, it's very hard to see because there's all these shadows. So there's actually a mechanical switch, on-off switch, right there where my finger is, right there. So when you turn it the full way, it physically opens a light switch. That would be the best. If you can find potentiometers like that, that would be perfect, because you don't want full resistance, because then it's consuming energy, and we want to be as efficient as possible. But that's what you do. You buy this $7 module, you unsolder the voltage one, you make sure the amperage one is at max, you unsolder this one, then you would have wires running from it, and you can put it in an electrical box. Let's go over here. So they're all down here. What a mess. Sorry. So yeah, you can fit it down inside there. See, it's size comparison. very, this is very big. This can fit down recessed in. And then you can take a blank plate, like there's plates without a notch, and then you drill your own notch, and then you physically connect one of these guys to it. But you have to reinforce this plastic, so maybe it's better to have a metal one. So yeah, do a metal one. Make sure it's grounded, just to be safe. You don't want to be electrocuting yourself. So, metal plate, that's a blank one. Then you drill your own hole for the dimmer knob. I used to have a bunch of knobs. I have ones for these guys. You can order them. They're cheap, pennies, no issue. So yeah, you get electrical box, you get this module, you get a potentiometer, and then you can, you can do it up. It's pretty good. So yeah, you just do that. So yeah, you'd be, for 4 of these lights running, they're very bright. They are very bright. Looking at them burns your eyes. It does hurt. It actually does hurt. And just from the side, right, they're pointed straight up. I'm looking at them from a 90-degree angle, and it hurts the eyes to look at them. So, very good quality lights. And when they're fully dimmed way down, 2.5 watts, max brightness, 37.7 watts. For 4 of them. This is for 4 of them, because it would be too much. Like, the higher your numbers, the less your inaccuracies are. So if I had 8 of them, I'd have a more accurate number, in my opinion. But, okay, I just did the math really quick. So it's like 9.7 watts per light bulb at full power. And it's like half a watt per light bulb at, like, just glow-in-the-dark brightness. So, that's a good comparison. Yeah, it's, I think that's it. 17-minute video, Jesus. Alright, well, I hope you liked this video. I hope it gave you some useful information. Yeah, pretty simple. I'm pretty happy with these results. I think this is a real option that we can use for houses, especially. This pack here would run these lights forever, right? You would need nothing. And if I did a jewel ringer design like this device here, I can run this with this module. I can run these 9-watt LED bulbs with no heat sink for like 8 hours off a AA battery. So imagine what I could do with a giant battery pack. But I don't see the point in that. Manufacturing is way too much. You just order a bunch of these guys, some potentiometers, faceplates, and metal faceplates, and that's it. Very, very cheap, extremely efficient, in my opinion. $6.50, $7. The faceplate is like $3, $4, $5. It's kind of a rip-off for the metal ones, but not a big deal. And then potentiometers are pennies, so pretty sweet. Yeah, you get a ton of light and a dimming capability for almost nothing. So I hope you liked the video. Let me know what you think about this. I showed you my numbers. I know they're very difficult to read and understand because they're all over the place, but let me know what you think. Let me know if you think this is a good idea. Are you going to do this? Are you going to buy these parts and install this in your house? Let me know. If you do it, please send me pictures. Let me know, because that would be amazing. Anyways, thanks. I'll keep you updated on this. I have other videos with other projects that I'm working on. High drain BMSs, stuff like that, but issues, lots of issues. Also, Andy Ham, if you're watching, I just can't get the parts to change the voltage for the APC you gave me. If you do have that serial cable, let me know. Like, I'll pay you just to let me borrow it, because I'm stuck at that point. And I can't get the software either. I can't find the software for the serial cable. So Anyways, hope you guys liked the video. Please comment, let me know what you think, and subscribe if you want to see more. Thanks guys, bye.